just a deposit.
Yeah. Okay, now I'll pull it out of her nose. We don't need to see that.
Wait till you see
Okay.
it.
All right. Now, what I wanted to show you, can you fire that up now? Oh, you have to hold it?
Yeah.
May I borrow this?
I was gonna put the pencil.
Try that.
Yeah, that works better.
Is that better?
But
All right. there
makes
we
it kind of bright, but yeah.
go. Yeah, that's okay.
Find a video of them doing humming instead of
Oh, yeah, I don't know.
Mm.
No, you can't because, well, you guess you could because you have to keep your mouth shut. You can't hum with your mouth open. Yeah, it doesn't sound right. Sounds like Seven Dwarfs or something. All right, now, so here we go. First of all, we have a wave. Boink. Whoa. Okay, now this is really slow motion, and this isn't fixed at the end, so it bounces up and down. All right. And then it comes down the other side because that's fixed, and it bounces up and down. All right? Now, if I change it so that this is fixed, it's going to come back the other side. So it gets to the end, it gets reflected back the other side. All right? All right. Now, I want to show you a couple of things. First of all, what happens when two waves meet?
Take a paper.
Let's see. Okay, so there are two waves. They're about to meet. Here they come. They're coming in from opposite sides. Look at that.
They close.
All right, the two waves, because one's on top and the other's on the bottom, they kill each other off. All right, they actually kill each other off. And then they go through each other. Watch how this works. Remember, this was the bottom one coming in. This was the top one. And they go off again. Now here they come again. And they go through each other. All right? All right, now, conversely. Oh, shoot. Okay, this one bounces off. Now, here they come. Here they come. Look at the size of the wave. What do they do to each other?
They converge.
They help each other out. All right? In the first thing it's called destructive interference. One kills off the other one. In the second case, it's called constructive. Now, who cares? Here's the deal. If you set up a set of speakers, okay? If you set up a set of speakers and you got a speaker doing this and a speaker doing this, so there's a speaker here sending out waves and there's a speaker here sending out waves, all right? And those waves meet. There are going to be places where there's constructive and destructive interference. There's going to be places where the wave crests meet, right? And those are going to be constructive. They're going to build on each other. But if you set it up badly, there are going to be places where there's destructive interference, where the top of the wave meets the bottom of the wave, and it'll actually kill the sound. You can make dead spaces in your stereo.
Possible.
All right? Well, it isn't cool, because then you got like a dead zone in where you set it up. All right? All right, so real quickly, let's go over the questions. I'm about to bring the lights up, so prepare your eyes and your mind. Here they come. Ready? There we go. All right. Always try to give you fair warning. All right, so real quickly, through the questions. On the front, very simple. Number one, all we did was made a single wave. Am I still in the screen thing?
Oh, yeah,
All
yeah.
right, good. Okay. All we did in number one was we made one single wave. So it was just a simple, look, there's the thing is on the one side as opposed to the other. All right? So we just, number one, or two, excuse me, would just been like, oh, slinky, and then the rest. Number three was, oh, let's make a bunch of waves. All right? Just keep going. And number four would have looked like what? Here's the compressed bit of slinky and the rest of the slinky. Later it would have been the rest of the slinky, compressed bit of slinky, the rest of the slinky. That's all I'm looking for. All right? And then the questions on the back. What happens to the frequency when you increase the rate? How often do you get a slinky? If you wave your arm back and forth fast, you get a lot of waves. Yeah. All right. What happens to the wavelength when you wave your arm back and forth fast? It gets smaller. Right? The frequency goes up, but the wavelength goes down. They're inversely proportional. All right? Now, transverse versus longitudinal. Did you look them up like I asked you to?
Yeah.
Well, that's a shame. All right? So, it would have been helpful. All right? So, trans means across. So, transverse is to go across or across. So, trans is the kind of wave that went up and down. All right? So, which ones were the up and down waves? The first three or the last one? First three were transverse. They went across. Longitudinal wave, where it was compression wave. Where did you see that? In the fourth one. All right. What is the relationship between the rate at which the spring is moved back and forth and the frequency? Is it directly proportional or inversely proportional? In other words, how fast you move the slinky, is that directly proportional or inversely proportional? Can you get me on screen here, out there? All right, man, I must have just been huge in the image. That would have sucked. Ah, look at that ugly old thing. All right. So, frequency. In other words, how fast you move it in the frequency, is that directly or inversely? Is the energy directly or inversely? Directly. And how about the wavelength? Inversely. And what are the parts of the wave? And what are the things? The wavelength, the crest, the trough, or the throw, or whatever you call that thing. Okay?
The
The
test.
trough. The trough. All right.
English is dumb.
We'll go with that. All right. Anybody have any questions on that? Could you kill that?
Mm.